powers of the US. In order to survive the hour-and-a-half journey through this radiation field necessary to reach the moon and return, solid lead shielding between the astronauts and the exposure outside would be required. The mammoth Saturn V rocket used by Apollo was already 35 stories tall and weighed as much as a battleship. To add additional tonnage in the form of a lead barrier completely surrounding the crew members would have made it impossible for the vehicle to get off the ground. That is why the Soviets, though more advanced, only sent an unmanned probe to the moon. The Apollo spacecraft's narrowest shielding was less than 1/8 of an inch of light aluminum. In 1998, the Space Shuttle flew to an altitude of 350 miles, one of its highest altitudes ever, hundreds of miles below the beginning of a field of radiation that was so severe that the astronauts inside of their shielded spacecraft and inside of their shielded spacesuits saw flashes of light with their eyes shut that they described as shooting stars, due to radiation penetrating first the shuttle's shielding, then their spacesuit shielding, then their skulls, and finally the retinas of their closed eyes. As a result, CNN issued the following report noting NASA's unpredicted surprise. The radiation belt surrounding Earth may be more dangerous for spacewalking astronauts than previously believed. Scientists say the phenomena known as the Van Allen belts can spawn killer electrons when the Earth's magnetic field changes. These electrons that are being studied could have an important effect not only on satellites, which has happened in the past, but could also affect the astronauts by creating large doses of radiation that could influence their health. The electrons can penetrate through various materials, including spacesuits, and can pass through, in fact, the walls of the space station, and can create high charges deep inside of these objects. President Kennedy, a man of political, not scientific background, set the irrevocable goal of landing a man on the moon by the end of the 1960s, just days after America's first astronaut had spent a mere 16 minutes in space, not even achieving a single orbit around the Earth.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
We take an additional risk by making it in full view of the world. But as shown by the feat of astronaut Shepard, this very risk enhances our stature when we are successful.
The technology necessary to launch the massive Saturn V rocket and an intercontinental ballistic missile is 95% similar. When the Soviet Union launched mankind's first satellite, Sputnik, in 1957, there was grave concern that they had mastered space ahead of the United States and might use this advantage to launch a first nuclear strike from an orbit high above North America. When they also put the first animal in space, then the first man in space, then achieved the first spacewalk, the first crew of 3, and the first ever of 2 simultaneously orbiting spacecrafts, concern turned to fear and then horror as America watched their communist enemy achieve all these firsts with no hope in sight of ever catching up.